This is Mr. Smith here. This is Algebra 2. Welcome to the rock. Or welcome to Section 8.3, which is going to rock you. Something like that. All right, so in this section we are looking at graphing rational functions. Okay. Still graphing rational functions. But this time we're going to expand our discussion to any polynomial. Okay, so this slide is going to be very important. I'm going to leave it up here for several minutes. So when we talk about a rational function, it is a polynomial, p, divided by some polynomial, q. What we saw yesterday was we talked about linear divided by a linear. Okay. Of course, that's a very limited discussion. We want to talk about rational functions of any type. So we need to expand our definition to talk about any polynomial p over q. Now, the good news is most of you are looking at this thinking, man, this is really scary. We can, for all intents and purposes, just kind of ignore this. It's there to be there for a technical reason, but it's not going to help your knowledge at this point, so we'll just kind of ignore it. And what we have is a three-step process, but step 3 kind of has 3 choices. Okay, so it's a 3-step process, but step 3 has 3 different possibilities, so we just got to be aware of that. And so here's the idea. Step 1, we find the real zeros of the topmost polynomial. So the polynomial in the numerator, we find the zeros of that, and those are the x-intercepts. Let me say it again. First, I'm going to take the polynomial on top, whatever that is, and I'm going to try to find the zeros of that polynomial. And those zeros will be the x-intercepts on the graph. That means the graph is going to go through those points. Step 2 is going to be to find the zeros on the bottom. Okay, so I have a polynomial on the bottom, q. Right, we'll call it q. So it's in the denominator, and I'm going to find the zeros of that polynomial. Okay. So step 1, find the zeros of the top polynomial. Step 2, find the zeros of the bottom polynomial. And notice we're only interested in real zeros. So these polynomials may have imaginary zeros. We don't care about those. We only care about real zeros. All right, in step 3, on step 2, that gives us our vertical asymptotes. So step 1 gives us the zeros. That's where the graph's going to cross the x-axis. Step 2 gives us our vertical asymptotes. Step 3 gives us our horizontal asymptotes, but now there are 3 cases. So what we have to do is we have to take our 2 polynomials, and we have to look at the degree of each polynomial. And so we call this m and n. Okay, we call that m and n. And now we're going to look, and we have 3 choices. So for the horizontal asymptotes, we have 3 choices. And they are either m is less than n, m equals n, or m is greater than n. Okay. In the first case, m bigger than n, this would be like m less than n. This would be like a quadratic divided by a cubic, or a cubic divided by a quintic. So this would be m less than n, and so the horizontal asymptote is the x-axis. If we have m equals n, this would be a case like we saw yesterday, linear divided by a linear, quadratic divided by a quadratic, cubic divided by a cubic, right? And so what we do is we just look at the coefficients of the leading terms, the leading coefficients, and we divide those, so a sub n over b sub n. We divide those, and that gives us our horizontal asymptote. Or case 3, m greater than n. This would be like a cubic divided by a linear, a cubic divided by a quadratic. Okay. And in this case, we won't get a horizontal asymptote. Right. So I'm going to pause for a moment for my students in class so they can get this all down, but this slide is the key to everything we're going to do in this section. All right, so here's our first problem. And so step 1 is to find the zeros of the polynomial. So step 1 is to find the zeros. And to find the zeros, I take the numerator and I set it equal to 0. All right, I look for a value that's going to make the numerator 0. So what number could I plug in that's going to make the numerator 0? How do you make 3 0? You can't. So there are no zeros. There are no zeros because and this is a little bit shady. This isn't. Is this a polynomial? Yes. Yes, it is. It is a constant polynomial. 3 is always 3. It'll never be anything else. 3 will never be 0. Therefore, this graph never has any zeros. Okay? That's part 1. All right, very interesting, kind of bizarre. Part 2 is we're looking for the vertical asymptotes. And the way we find those is by setting the bottom, the denominator, x squared plus 2, we set that equal to 0. And we look for real values that solve that. Real values that solve that. What are there any real values that solve that? The answer is no. Hopefully most of you see that right away. Look, I could go do this, but this isn't going to give me a real solution. All right, so vertical asymptotes, there also are none. This is shaping up to be quite bizarre. Horizontal asymptotes. So in this case, we have to talk about the degree of the polynomial. So the bottom one is a quadratic. I think we're all good there. The top one is a constant. So the progression goes constant, linear, quadratic, cubic. Right, so if anything, we could call this as x to the 0th power if you really need to see something there. Because anything to the 0th power is just 1. So in this case, I have m, which is 0, and I have n, which is 2. So I have 0 is less than 2, m is less than n, so we're in this first case. The line y equals 0 is the horizontal asymptote. Okay, so I go to this chart and I compare my m's and n's. And I get the horizontal asymptote in this case is the x-axis. So it's not really a whole lot to go with. So the only way that we're going to get more is by going with an xy table. And we pick some x values. And by the way, remember, this is just 1 up here. So if I pick an x value of 1, I get 1 squared is 1 plus 2 is 3. 3 divided by 3 is 1. If I plug in 0, I get 3 divided by 2, which is 1.5. If I plug in negative 1, I get negative 1 squared, which is 1 plus 2 is 3. 3 divided by 3 is 1. If I plug in 2, let's see, I get 4, 6. 6 on the bottom, 3 on the top. That should be 1/2. And so this is probably enough for us to graph this. So we get a graph. It does that. And it never touches the x-axis. Remember, the x-axis is an asymptote here. And there we are. Now, recall that since there is no vertical asymptote, the domain here is going to be all real numbers. The other way to think about this is, look, there is no number. There's no number that's going to make this thing 0 on the bottom. Give me any number. I dare you. Any real number, and plug it into the bottom. You will never make that 0. Therefore, the domain, all real numbers. What about the range? Anyone bold enough to talk to me about the range of this graph? And I'll tell you in section 8.3, we're not going to talk about ranges very much, because ranges get very hairy very quickly. What do you see here, though? What is the range of this graph? Any takers? Because otherwise I'm going to start calling on you by name while we're recording. And your answer will be left in infamy forever. Come on. Any takers? What's the range of this graph? You there. What's the range of this? I don't know. That's your answer? That's how you want to be remembered on this video? I don't know. Remember, when we talk about range, we're talking about the y values, and we start down here, right? Is the graph down here? No. Okay, so we know immediately it's not going to be all real numbers. You, sir. Bravo. Bravo. You shall live down in history with your answer. Yeah, the range here, and it's probably easier to think about this writing in this notation, is going to be from 0 to 1.5, right? As I keep coming up the y-axis, the graph doesn't start till 0 and it ends at 1.5. The question is 0 included? No, it should not be. Is 1.5 included? Yes. That is the range of this graph. It's a little bit beyond us, but not really. You guys should be able to do that with confidence. All right, moving on. Here's a practice problem. Practice this at home. It's on the video, along with that wonderful answer. Next problem. Okay. We have 3 steps. Remember, step 3 has 3 different options. Step 1, we find the zeros. To find the zeros, we set the numerator to 0. X squared minus 9 equals 0. And I want to know what values make that 0. Well, this is a quadratic. Quadratic should have 2 solutions. What are the 2 solutions? 3 and negative 3. I'm going to write it like this as a shortcut. So that means the graph is literally going to cross those points. Okay. Next step, vertical asymptotes. Vertical asymptote. To find the vertical asymptotes, I set the bottom equal to 0. So x squared minus 4 equals 0. I solve that. Does it have real solutions? Yes, it does. What are the real solutions? 2 and negative 2. This is where our vertical asymptotes are going to be. Okay. There we are. There we are. This is also enough knowledge now for us to talk about the domain of this graph. The domain is going to be x a real number, such that x not equals 2 and x not equal to negative 2. Okay. There's a horizontal asymptote. So we have to look at what case this is, right? There are 3 cases. But we're in the case where I have a quadratic x squared divided by x squared. So we go back, and here we're in case number 2 now. M equals n. So how do I find the horizontal asymptote? The line is y equals the coefficient of the top divided by the coefficient of the bottom. So the coefficient here is 1. The coefficient here is 1. So y equals 1 over 1, which of course is just 1. And that gives us a horizontal asymptote like that. Anytime you see this grid of 6 squares, right? 1, 2, 3, 4, 5, 6. Do you see all 6? The way this graph is going to behave is we're going to have a part down here, either bottom, top, and the bottom, or it's going to go in the top, the bottom, and the top. It's got to alternate in that fashion. But since I know that there's part of the graph that goes through this point, and part of the graph goes through this point, it's going to be bottom, top, bottom. And since these are asymptotes, the graph has to get closer and closer to each piece. Right? So it's got to get close to this asymptote, and the graph's got to get close to this asymptote. And so it's going to look like this. And now to fill in the rest, there's got to be part of the graph that comes up here, and that part will get closer to this asymptote and closer to this asymptote, and then we're kind of fudging how that's going to look there. But it looks roughly like that. Again, for the exacts, please refer to your graphing calculator. It'll get this exactly right. One thing to note, though, we're not going to talk about range here. We're not going to talk about range because there can be a little bit of a gap between the top and the asymptote, and there's no way to know what that gap's going to be without looking at the graph. So this might be an example of a bonus question for me to ask you about the range of of this, and you would have to use your graphing calculator to do that. Okay. On the bottom side, it's not a problem. This line will get closer and closer to this asymptote. On the top side here, though, this doesn't have to get close to the asymptote. Okay. All right. So this is the second case. All right, one last problem. Here we go. Step 1, we want to find the zeros. To find the zeros, we set the top equal to 0. How am I going to solve that? Right? If I want to set the numerator equal to 0, how do I solve that? It is a quadratic. So I can either use a quadratic formula or factor if it factors, which this factors. So this is an example where we do not get to forget the knowledge that we've learned. Okay, so these are the zeros. By the way, careful as you're watching, my graph is scaled by factor of 2's. Okay. Let's talk about a vertical asymptote. To get a vertical asymptote, I solve the bottom equal to 0, x plus 2 equals 0, so x equals negative 2. That means there is a vertical asymptote here. Vertical asymptote there. Okay. It also tells us we can talk about the domain now. The domain will be x is a real number such that x not equals whatever our vertical asymptote is. Negative 2. Last step is the horizontal asymptote. To get the horizontal asymptote, I have to go back to my table. I see that this is a 2 over a 1, right? So m is bigger than n. By the way, I would like all of my students to memorize this. This will serve you in pre-calculus. So m bigger than n. So the graph has no horizontal asymptote. So none. And now we're supposed to graph this. We have very, very little information to go on. Honestly, the only way you would be able to graph this would be by hand to make an XY table from here and try to finish this off. Okay. I'm going to show you what the graph looks like now. Personally, I'm less concerned with this. And the only way that I know how this graph looked is because a student showed me their graphing calculator this morning. That is what the graph of this looks like. Again, we have an asymptote behavior here on the vertical asymptote, so this line is going to get closer and closer to the asymptote, and this is going to get closer and closer to the asymptote. And that's what this graph looks like. Does anyone see anything interesting going on here? Go ahead. So on both sides here, go ahead. So what we need to be clear on is there is a horizontal asymptote. However, there is, and I didn't draw this well. Part of it's my drawing. But if you look at it, there is another asymptote. This is a slant asymptote. And what it means, what it implies, is that this line, the graph will keep getting closer and closer to this slant, and it'll keep getting closer and closer to this orange line. The graph will keep getting closer and closer to the orange line, and it is a slant asymptote. I have some good news and some bad news. The good news is, in algebra 2, we don't talk about slant asymptotes. Calculus, you do. Okay, so for the sake of our class, we're only going to worry about horizontal and vertical asymptotes. But you should see that there are such things as slant asymptotes, and in pre-calculus, we want to know what is the equation of that line. We'll actually go, there's a way for us to find that. Oh, joy. Okay, so here are two problems, kind of finish off the lesson. So if you would work on these two problems, if you're at home, pause the video, and then I'll walk through. All right, thanks. Okay. So welcome back. So what I did, again, more than anything, I'm going to be concerned with, can you identify the vertical asymptotes, the horizontal asymptotes, the zeros, more than graphing. In this first one, we set the top to 0, bottom to 0, and we used our rules to figure out the horizontal asymptote. This is our sixth grid, so it means on this bottom one, we're going to be down here, and we're going to go top, bottom, top. On this guy, on the second one, we are going to have no horizontal asymptotes. This is going to be one of those cases where we get a slant asymptote again. Again, on this, I'm really going to be less concerned on the graphing and more, if you want to graph this, look at the graphing calculator. Thanks for your attention. Have a good day.